In this video, I'm going to do a few more examples of integration by parts. This time, we're going to introduce the natural logarithm to the process. So when we have the natural logarithm, ln of x, we're always going to make that our d. So you remember from the previous column we have two columns, the derivative column and the integration or antiderivative column. And in the derivative column, whenever we have a natural logarithm, we are going to let that be what we put in that column. That means that in the antiderivative or integration column, we are going to have 11x. So let's put 11x over here. So the algebraic or exponential part will always go over under I because the logarithm will always have to be d. And the reason for that is right now we don't know how to find the antiderivative of a logarithm. All right, so the process now starts off the same but quickly changes slightly. So in the derivative column, we want to find the derivative of the log of 4x. So you remember that that's going to be 1 over 4x times 4, the derivative of 4x, using the chain rule, which becomes 1 over x. So I'm just going to write that down here. And just like we did before, we want to put a plus here and a minus here, but I'm also going to put a minus and an integral sign. Then under the integration column, we're going to integrate this, so we would get 11 halves x squared. All right, that's it. We are done. We only have to go this far whenever we have a logarithm. So what we're going to do now is we're going to take this and we're going to make a diagonal just like we did before, multiply that. So let's do that. We're going to have 11 halves x squared times the natural log of 4x. Now we're going to do something a little bit different than our previous technique. What we're going to do now is we're going to do all of this. We are going to do minus the integral of 1 over x times 11 halves x squared. So that's going to look like this, minus 11 halves times the integral of 1 over x times x squared dx. So now we actually have to do some integrating. Unlike doing integration by parts with the tabular method with exponential and algebraic terms, with a logarithmic term, we just have to do one simple little integration here. So let's bring this part down. And now we're going to have 11 halves. And so the x squareds, these cancel, leaving you just an x. So we have the integral of x dx. And so that's just x squared over 2. So we have 11 halves x squared, the natural log of 4x minus 11 fourths x squared plus c. And now we are done. That is integration by parts when you have a logarithm. So the process is, let me erase a little bit of this. I get rid of some of the stuff we don't need here. Now, so we are going to do the diagonal just like we did before, but then we're going to go horizontally. So the diagonal in yellow was this, and then the horizontal was all of this over here. All right, let's do another one. In this one, we have a logarithm, ln of x, and we have something that's not a logarithm, just plain old 16. So under the d column, we're going to put the log of x, and under the I column, we're going to put the 16. And there's going to be a plus here. Now the derivative of log of x is 1 over x, and we want to put a minus the integral of. And the antiderivative of 16 is 16x. So we are now going to go diagonal and then across. So diagonally we have 16x times the log of x, and then going across we have minus the integral of 1 over x times 16x, and then we have to put the dx in there. And so the blue part was the diagonal, and the purple part was the horizontal. And we still have to simplify this a little bit and then do that one derivative. So we have the integral of these x's cancel out. So what we're left with is just 16 dx, because you can see this x and this x will cancel. And now actually doing the antiderivative, 16x log of x minus 16x plus c. One more, let's make this one a definite integral. So I'll do this up until the point where we would use Desmos. So you notice that we have a logarithm and we have a part that's not a logarithm, and these two different functions are being multiplied together. So under the D column, we have the log of t, and under the I column, we will have 6t squared. Plus goes out here. Well, the antiderivative of 1 over of t is 1 over t, and we put minus the integral of, and then 6t squared, finding the antiderivative would be 6t cubed over 3, which is 2t cubed. And so now we want to do the diagonal, which will be 2t cubed log of t, and then we want to do the horizontal, which will be minus the integral of 1 over t 2t cubed dt. And again, this t cancels with one of those t's, leaving us with 2. And so we have 2t cubed log of t minus the integral of 2t squared dt, which becomes 2t cubed log of t minus 2/3 t cubed. And all of this is being evaluated from 1 to e. All right, so this is our antiderivative. In Desmos, we would simply let that be capital F of t. Make sure they put it into Desmos very carefully. And then on the next line, you're going to evaluate f of e minus f of 1, and that will give you your answer. Voila. All right, so that is what you need to know about integration by parts with logarithms.